I gotta turn. There you go. Okay. Hickey. Here. Brooks.
Yeah.
Bullock. Here. Logan. Newquist. Pretzel.
I mean,
Dean Schlottman.
Here.
You have a quorum.
All right. So can I get an approval of the minutes for the landfill committee meeting, February 11th, 2025?
there's
Thank you.
There you go.
Hickey.
Yes.
Brooks.
Yeah.
Bullock.
Yes.
Logan. Pretzel.
yes.
Dean Schlottman.
Yes.
Approved.
All right, moving on. We have no old business, but we do have some new business today. We have some, we have a presentation for some of the ideas for the expansion of the landfill. So I'm gonna want to hit your button. And we are gonna go ahead.
Good
Go.
morning.
Good morning.
Thanks for
Everyone
having,
should be
thank you
super
for having me.
excited.
I've had the pleasure to attend several of these landfill committee meetings in the past. Happy to be here again. I know there's some new faces here from last time when I was here. So I thought maybe just start with a quick reintroduction of myself. I don't know who's controlling the show there, but if we can move through. So my name is Marty Fallon. I'm an operations manager for a company called Geologic Associates, which is located just up north here in St. Charles. I'm a geologist by education, and I have been spending my whole career, almost 25 years now, working on projects like this, siting, designing, and permitting of waste management infrastructure, like landfills and transfer stations and recycling facilities and compost sites and whatnot. So we are the county's consultant for siting a expansion of the Prairie View landfill. If we can go to the next slide, please. Just quickly, this is the existing permitted design. That's the final landform. It's not fully built out yet. Right now, they're moving from west to east, and I would say they're about 2/3 to 3/4 of the way across, and currently working in that eastern third, building that up to grade. The existing landform has an undulating, call it kind of a lumpy, I guess, design to it. It has slopes ranging from 10-to-1 to 3-to-1, and has approximately 9 years of life left at current filling rates. A couple more things I want to point out on this slide. So we're going to get to it in a minute, but one of the areas we're looking at pursuing an expansion is off to the northeast, top right on the slide. And a couple of features I wanted to show you up there in the turquoise. Those are floodplains. So there's a couple of streams that run through the property. There's a darker blue shape there. That is a permitted stormwater basin for the existing landfill. It takes stormwater off the landfill and retains it and releases it slowly off site. And then that darker brown orange colored feature, that is a soil stockpile. If we can go to the next slide, I want to talk a little bit more about the stockpile. We've done some rough estimates. The stockpile contains about 1.4 million cubic yards of material at current. That is a designed stockpile or as part of the existing design. That soil is generated from excavating of the landfill cells, and it's put over in the stockpile. And then some of it is used then during operations to be pulled back for daily cover or intermediate cover and final cover. But the current design calls for about 1.6 million cubic yards of surplus soil. So that's almost, it's going to get a little larger, but that's part of the existing facility design. The reason I'm spending some time talking about it is because if we're going to expand up in that area, which we intend to attempt to site expansion there, we're going to need to find some offsite property to relocate that soil. Go to the next slide, please. We have to this point generated dozens of different iterations of concept designs, looking vertical only, horizontal and vertical, property to the south. We've pretty much exhausted all the options, and just, I guess, earlier this year, we've kind of come to a consensus among our group that gain some traction on a direction that we want to go. And that is to cite both a vertical expansion option and a horizontal and vertical expansion option, and to run those parallel and to get approval to do either. And then, depending on whether we're able to find some offsite property to move that soil, we would, obviously the horizontal and vertical expansion is going to get us some additional years of life versus just the vertical. And I'll get into that in a minute here. So planning to move forward with both options. We can go to the next slide, please. So this is the first option. This is a vertical expansion only. So this is staying within the existing waste footprint and just adding more waste on top of the existing landfill. So we've taken those undulating slopes, we've made them more uniform, and we've taken that basically up about as high as we can go based on the geometry of the site. That provides us with approximately 24 and a half years of additional life. It doesn't require us to move that soil stockpile. We don't need to get up into the area with the wetlands. And we believe that the existing stormwater infrastructure will be sufficient for this. We will model it. Also point out that this is just conceptual. So we've got some engineering calculations to do, slope stability. We're looking at the pipe networks on the bottom of the landfill to see if the pipes can handle the additional weight of waste. Our preliminary calcs say that it will, so we can pretty much go as high as we want within the geometry of the site. Go to the next slide, please. This is our second concept. I'm not sure why the white box there, but the idea here is this is basically the same as the previous concept, except this also includes that component where we're pushing off to the northeast with some new landfill cells. And this option would provide about 10 years of additional life in addition to just the vertical only option. This does require moving of that soil stockpile. There's a roadway over there that would need to be vacated, but we think that this is also a very viable option that we'd like to pursue in the event that we can find a place for that soil. And move on to the next slide. So both of those designs basically took the final landform as high as it can go. That's about 170 feet higher than the existing permitted landfill. And there's some play there, so we don't have to go that high. We think we can. And just to put that into perspective, we have done some line of sight renderings. So what this slide here shows is a view from Highway 53 looking east. Really the perimeter of the site along the exterior roadways is very wooded. So there's a line of trees, so you really can't see in there, but there are a few gaps, and this was one of them. And if you see up in the top left picture, that is the existing landfill. That's what it looks like today, rather. In the center on the top, that's the permitted. So once it's fully built out, that's what you would see. And moving around top right, that's if we went 45 feet higher. Bottom left is if we went 65 feet higher. And then the bottom middle, that's the design that I showed you where we're 170 feet higher. So you can see, really driving by, it's not very noticeable. So still something we're going to look at, but I would, my recommendation would be to the county that we try and get as much airspace as we can out of the landfill, as long as the engineering calculations bear that out, that it's feasible. So if we can go to the next slide, this is very similar. This is from the Medewin Visitor Center, which is right over there on 53 as well. So similar, exact same views you get. Top left existing, bottom middle would be that 170-foot increase. So you can see it's a very undiscernible, I guess, in my opinion. If we can go to the next slide, this is a gap on Arsenal Road. Arsenal Road similarly has a nice line of trees along it. You can't really see in except for right here at this driveway. And then it's much more apparent here, the difference between the top middle, which is a permitted design, and the bottom middle, which would be what I showed you in those concepts. So this is something we're going to be working on fine tuning that design. So that's where we're at. We've got our concept designs. Our next step is to conduct a site investigation. There was a very extensive investigation that was done for the existing landfill back in the late 90s. It was a very good investigation. I reviewed all the data. For back then, very impressive what was done. We are going to basically extend that investigation to that northeast. It was I'll show you shortly, but it was about a 350-foot grid of borings across the site. We're going to continue that grid spacing moving off to the northeast. And the idea of the investigation is going to be to characterize the site geology and hydrogeology and to obtain the geotechnical and hydrogeologic information that we need to design the facility. So get the engineers the information they need to design the baseliner, get our geologists the information that they need to develop a monitoring network and to do the modeling required by the state, contaminant transport modeling. And really, we want to verify that the geology that we see in that horizontal expansion area is consistent with regional publications. We want to verify that it's consistent with the information that was documented at the existing facility. And if it's not, then we would adjust our design as needed. Ultimately, we want to ensure that when we take that design and we stick it in that site geology, that it's going to be protective of the public health, safety, and welfare. I've stuck some geology slides in here. I hope you don't mind. This is my favorite topic. So I hope I'm not going long, but I love geology. A little glacial history of this area. So as recent as 13,000 years ago, right where we're sitting here today, was covered by about 2,000 feet of ice during the last glacial period. And that ice, as those glaciers came into our area, they would come in, they would stagnate for a while, they would back up, then they would come forward, stagnate again. And that's what you can see here when you look at the graphic on the right side of the slide. Is all of those white or light blue arcs, those are places where the glacier came forward, stopped for a while, and glacier acts like a conveyor belt. So it would take material and it would deposit it at the front of the glacier. So those areas have a lot of clay, much thicker than areas that are more blue in color, although the entire area is covered in clay that was deposited by those glaciers. That clay is very dense. And the reason it's so dense is because there was 2,000 feet of ice and all that weight of that ice compacted that clay. And that's what makes having that nice compacted clay makes a nice spot for landfilling. You can jump to the next slide, please. Just getting a little sciencey here. This is a picture of microscopic clay particles. So this is the reason why compacted clay inhibits groundwater movement so well, is that they're very flat and platey particles, and when they get compacted, they lay on top of each other, and they perform or they create a barrier that inhibits that groundwater movement. Go to the next slide, please. So this is a map. This was put forth by the Illinois State Geological Survey, and basically it was a map of the state showing the areas that have high or low potential for aquifer contamination from land burial of the municipal solid waste. So just showing we're located on that Rockdale moraine from that previous figure. It's got a thicker clay and is a very good spot to put a landfill. So just a little geological background there. This is a bedrock map. So this shows the different bedrocks across the area. That purple where we're located, basically the whole Chicagoland area sits above what we call Silurian dolomite. It's very similar to a limestone. It's commonly mistaken for a limestone, but that's basically what all of our Chicago skyscrapers are founded on, that Silurian dolomite bedrock, and that's the same bedrock that we have below the landfill site. We can move on. This is a generalized geology of the site. So we have what we call the Lamont Formation. That's that nice glacial till. We have that's at the top there in gray. Above that is a Peoria silt. That's a windblown silt. It's basically the topsoil we see across the area. In the a little bit of a darker blue, that's called the Equality Formation. That is a lacustrine silt and clay. It's a lake deposit. So glacial lakes that would form behind one of the glaciers in front of the next back glacier would be a lake deposit. So it's very fine laminated layered silts and clays. a little smaller bit of that Lamont Formation above the slurry and bedrock. And then in the brown color, we have what we call the Henry Formation. Those are just discontinuous pockets of sand and gravel that form within the glacial tills. We can go forwards. This is a cross section of the existing landfill created back there in the late 90s. And I've taken some blue lines and kind of delineated so you can see just in a more realistic cross section what that geology looks like. This cross section you can see on the right side of the slide, it's running from west to east and then leading right into a horizontal expansion area. So if we were to visualize that cross section continuing, that's what we expect to see when we go out there and drill. We can go to the next. So our plan, and I'll show you a map here in a minute, but is to go out there and add to those 60 or so borings that were already advanced out there. We're going to add 9 additional boring locations to supplement that previous investigation. We're going to, in each boring, we're going to collect samples. We're going to send those to a geotechnical laboratory for various testing, triaxial shear testing, permeability testing, moisture content. We've got a whole gamut of tests that we're going to run. We're also going to install piezometers. We'll talk about those here in a minute, but help us allow us to evaluate the aquifer and collect groundwater elevation data, aquifer data, and several other pieces of information. Go to the next slide, please. On the right, that's a schematic of a piezometer. If you were to look at it in cross section, it's basically we'll drill a hole, and then we'll lower down a 2-inch PVC pipe into that hole. The bottom portion is perforated. We'll pour some sand around that perforated section, fill the rest of it with grout, and then finish it off at the surface with a concrete pad, some bollards. And that will allow us to do testing on that screened area and measure aquifer flow, groundwater elevations, those types of things. So on the left side of the slide, that's a drill rig there. I'm not sure what site that is. It's not your site, but just a typical example of a drill rig. And then that's what a piezometer nest looks like at the surface. So those would be 2 different piezometers screened they're within 10 feet of each other, but screening different zones of interest. So this is that same geology schematic and just showing, where we might screen. So this is where we intend to target for this investigation. The uppermost aquifer permitted by the IEPA at the site is that uppermost portion of the bedrock and the bedrock interface with the overlying materials. If we find any of these discontinuous Henry Formation pockets of sand and gravel, we'll put a screen in there as well so we can evaluate those. And then a couple locations, we're going to also go a little deeper into the bedrock so we can calculate a vertical gradient and figure out how the water's moving horizontally, but also how it's moving vertically. So here is our site investigation overlaid on the existing design. You can see in very lightweight gray, you can see the existing borings, and then you can see in the colored circles is our extended investigation. So keeping on that same grid, that will allow us to continue those old cross sections east into our site. At each location, we're going to go at least 15 feet into bedrock. At those 2 orange locations, we're going to go 40 feet so we can put those, we can come up with those vertical gradients. And that's similar to what was done the existing landfill. Excuse me. We're going to do piezometers at all of them with the exception of the 2 red locations. Those 2 locations, that's where the soil pile is, and we don't want to inhibit access to use of that pile or ultimate moving of it. So we believe we can get enough information just by moving around, putting the piezometers around the pile and connecting it with information that we have at the existing facility. Go to the next slide, please. Same thing, just showing how those borings overlay onto the concept design. And you can see we have stepped a little bit outside of those boundaries of the concept that we've shown you, but the purpose of that is there is a chance that we may be able to extend those concept boundaries and eke a little bit more life out of that area of the site. So on this slide, just showing some of the various lab tests that we will do. planning on using a local geotechnical lab. I should say the driller that we're planning to use is a union drilling company, one that I have a good experience with. I have full confidence in them. If we can go to the next slide, please. Just some of the things this investigation, we're actually headed out there this afternoon to stake out some boring locations, identify areas where we can lay down some equipment and locate the water source, make sure we have the correct valves and whatnot on there. And currently we're tentatively scheduled to start drilling in 2 weeks from yesterday. So Monday, the 21st, right after Easter, if all shakes out. So that's just tentative. We think that the drilling, depending on how many rigs we throw at it at once, it would be 2 to 3 weeks in length. And then probably another week of aquifer testing, putting bollards in, that type of thing. And then we'll have quite a bit of work to do back in the office, putting together boring logs, as-built diagrams, how each piezometer was constructed, breaking down the results of our aquifer tests, creating potentiometric maps, extending those cross sections. So quite a bit of work is going to go into this once we have that field data collected. So I know we're not there yet, but at some point we're going to talk about when we're going to meet next. We can meet again next month, but we're probably not going to have a whole lot to say. Probably for a couple of months, I would think. And we can talk more.
What is that, 2 or 3 months for the testing to come through, or like
Yeah.
for all the data to be collected? And
Yeah, it takes the lab time to get the data back to
Right,
us. And we can give, or I can give Dave, just everything's, looking good, or we've, it's consistent with what we've seen, but we're not going to have anything fancy to show you for a little while. Ultimately, we're going to take the results of the investigation and we're going to fine tune the design. Primarily, that's going to have to do with the subsurface portion of the design. How deep do we go with the landfill cells? And maybe maybe with the waste boundary, can we expand that? How do we maximize the airspace on the site? Is there another slide? Just questions. So I'm happy to be here. I'm happy to be making some traction. I'm happy we're starting drilling. Happy to be able to update all of you on where we're at, and happy to answer any questions that anybody may have.
with the this design and the moving of that dirt pile, do we have a place in mind? Has that been talked about, where this dirt pile is going to move? And then I don't think this is probably a question for you, but what's that cost going to look like to move that dirt pile? Because it's a lot of dirt.
It's a lot of dirt. We've been exploring some options to move that. We have not fully vetted all those options yet, so they're still in flux, I guess I would say. But I would say the closer the better, because it is a lot of soil. It's going to be a lot of trucks, a lot of excavation, loading. So the closer the better, I would say. And the cost of that's going to depend on that distance.
Right. Okay. I just didn't know if there was possibly a place that we've already thought about. Kelly, did you have? Go ahead.
Yes. Hi.
Hi.
Okay, so you said that there are pipes under the landfill that you're checking to see how much weight it will hold, and that preliminary tests show that it will hold the amount
Correct.
if you go vertically. What happens if I assume you're doing more testing, that's why this is preliminary. So what happens if you get different data?
So what we're doing is we know the permitted design. They used a polyethylene pipe. It's basically, these are pipes in the bottom of the landfill that the bottom of the landfill is shaped like a sawtooth, basically. So we call it leachate. Any storm water, any water that touches that waste percolates down to the bottom of the landfill, and it will be directed down just based on gravity to the bottom of that trench. And in that trench, there's a slope on that as well. And there's a pipe in that trench, and that pipe then takes that leachate and brings it to a sump where it's pumped up and then out of the landfill. So it's those pipes. So we know how they were spec'd in the design. We've gone and we've looked at all the construction certification reports so that we just verify that it's an SDR 11. They call it a polyethylene pipe. And then we take the highest or the greatest thickness of waste above that pipe and what the weight of that waste is. And then we do a calculation to make sure that pipe can handle that weight, and with some factors of safety in there as well. So we've looked at it and it will work. We just want to, I'm not an engineer, I'm a geologist, so we haven't published a calc yet, but I'm pretty confident that we can go up, basically peak out that existing landfill if desired by the county, and the pipes can handle it.
Okay, so if the pipes can't handle it though, then you just go.
We just lower the.
All right, thank you.
You're welcome.
Okay, Member Bullock.
Thanks. Okay, so is the additional time frame 24.5 years, 35.5 years, if we expand, does that include the 9 years that are left, or is that on top of the 9 years?
On top of the 9 years.
Okay. And then if this all goes the way you see it, what is our time frame to is this an expansion thing that we're doing, as soon as you get everything back, or is it something we're waiting on?
No, we're moving forward. So first thing is to do is to get this investigation done, and then start moving forward on finalizing the designs. A siting application for a landfill is a huge undertaking. So typically these are 7 volumes of 5 or 6 inch binders. So it'll be an application like this, and it will have not only the design and all the backup engineering calculations and all the geology and the modeling, but there's operating plans, construction quality assurance plans, enclosure plans, traffic impact analysis, real estate impact. So there's quite a bit of people that are involved in that. So
like 60 days, right?
So we're looking,
6
I
years.
guess, as I sit here, we haven't mapped it out since we've started moving forward, but I would, depending on how involved the committee is and how often we are checking in here, I would say it's probably a year to a year and a half or more of time after we finish the geology to have an application.
Okay. And then I do have a question just to help. I mean, you threw a lot of science at me. Can we go up to 25? So the dark blue up at the top has been restructured from what it was before,
Correct.
right? So, and what was the dark blue again?
That's a stormwater pond.
Okay, so we're
So-
shifting it and it's,
Right, and we're gonna have to model that and make sure that that size pond is still gonna work, but there's 3 of them. There's one on the north, one on the west, or 2 on the west, and one on the south. There's 4 of them actually, but stormwater hits the landfill. It's directed off the cover into a perimeter ditch. It flows to one of those 4 different basins where it's stored, and then it's discharged slowly offsite. That's
it's
clean rainwater.
clean rainwater. The stuff that you're taking from the
Leaching.
leaching, what is that? And is that just, how does that, I mean, is there any kind of purification with that before
Yeah.
it goes someplace?
Yeah, so that's handled by a POTW, a treatment plant.
Okay, okay. All right, thanks.
You're welcome.
Mr. Brooks.
Marty, I'm one of the new people you were referring to.
Nice
I
to
love
meet
to
you.
keep saying that. On slide 10, 11, and 12, you don't have to turn to it, Tim, but there was a tower you showed with a flag at the top, the views from Route 53. And I didn't catch what was the purpose. A lot of the heights didn't look any different at all to me. But what was the purpose of that?
That's the purpose, just to typically when you're designing a landfill, height, can become a public perception issue. Is this something that's gonna, be an eyesore for the community?
Right.
So I guess the point of that was, to put the committee at ease that, this site is really buffered very well from the perimeter roadways. It's that Arsenal property was huge.
Mhm, mhm.
And so, the combination of the setback and the trees along the road is really, height shouldn't really be that big of a deal for the committee.
But nobody really noticed that you didn't put the flag, put the pole out there, though. Kind of calling the attention to it, though.
I'm not sure what pole or flag we're talking
Go
about.
back to, I think,
Now you
10
gotta
or
go back.
11, Tim. Where? It's like, now I know it's there. Oh, you passed. Oh, there they are. Yeah, that.
The
Right.
writing?
And then go up to the 10. Go up to 10.
Are we talking about the arrow and the writing?
Right.
Well, that was for your benefit, just to show you where to look on the,
No, it's another one. I think 11 or 12.
That right there.
Okay.
The pole, yeah, there we
All right.
go.
That's a power pole. That's in the foreground of the photo. So we snapped that photo from the,
That's in front.
yeah.
Yeah,
Okay.
it's like well in front of the landfill.
Okay, all right. Thank you.
Little perception there, the issue, that's all.
Sorry for-
Okay. No.
Confusion.
Yeah, okay.
We won't put a flagpole. on top.
Okay.
Member Van Dyne.
Thank you, Chair Dean Slotman. And my question kind of piggybacks off of Mr. Brooks. I've driven by the landfill for the last 30 years, it seems like, and if you're not actually looking over there to try to find it, you really can't see it from Route 53. But my question is, one of the slides was a little confusing to me, and it said we could go possibly 170 feet above permit. What is actually our permit now, and what would be the additional 170 feet? I guess I could add it myself, but
We're
what would be the
at,
total height?
That's a good question, actually. Can we go back?
It was quite early in the slide.
Yeah, so the peak right now is at an elevation of 795.
Which is above sea level.
Above sea level.
I think
So that's the permitted,
was Jolie at like 600. I'm just trying to figure out how tall the actual mound or the landfill would be above grade.
No, are we talking about 795 plus 170?
well, that would be that would be
Yeah.
the,
Okay,
so it'd be 965.
960, yeah.
The question is, what's the base grade in that area? That's a good question. So let's see here.
I kind of enjoy geology myself.
You gotta stop.
Yeah.
Member Van Dyne, Kelly can't take it.
Oh.
It's about 645. So
500 feet,
about 300 feet, maybe.
4.
So
465, I think is what he said.
Yeah, it'll be 150 plus 170, so 320 feet high.
Okay.
Does that answer your question? You still look a little,
Yeah. I feel like I need to redo the math, but I'll take your word for it.
okay.
300 feet tall? Okay. Thank you.
Yeah, that's what
He's okay, we're double, okay.
these they're not the resolution on this. I can't read the contour labels. That was a good question. They stumped me.
That was not my intent.
We'll get you that answer.
Yeah.
Okay. Are there any other questions right now? Yes, go ahead. Oh, yeah, click if you could, please. Thank you. There you go.
I just want to say I welcome any rolling hills you can make as we're driving through Illinois, so it's okay.
Okay.
So flat. Yeah.
The undulations on there is a nightmare for the people trying to build the landfill. The surveying is you can imagine. You got an excavator and you're.
Are there no other questions? All right, well, we appreciate you coming in and sharing that with us. And obviously, we will be looking forward to all of the data that you collect and bring forward to us when it's all finally compiled so we can continue moving the process along to get this landfill moving.
Thank you.
So
Looking
thank
forward
you.
to it also.
Yeah, well, it sounds like it. Hey, I like science stuff, so that's good. All right. From there, we have no other new business. Is there any public comment? Come on up. You could have just come up when you wanted, but. All right. Member Butler.
Hi. So I'm just speaking for members of the farming community outside of the landfill, and that there's a real problem with debris everywhere on the streets, all along the side when the trucks are coming in. And I would ask that this committee look into that and possibly remedy that and have these streets cleaned up. Thank you.
Is there any other comment? Sure. Go ahead.
Thank you. Mr. Butler's completely 100% correct. I know we do have a county highway that goes from I-55 to Route 53 and is consistently littered with garbage. And I wish there was a way to figure out how to monitor these trucks or do a better job of covering them up. But I know I've called the county's Department of Transportation quite often, and it's very hard to keep up with. So thank you for bringing that up, Dan. And that's probably not the only spot that it is littered. So
It's wherever those trucks travel, yeah. All right, any other comments? All right, I have no announcements. We have no need for executive session. So our next meeting will be May 13th, 2025 at 9 a.m. in this room. Can I get a motion to adjourn? All in favor? All right. See everybody.